Dave here. Today we are covering what is a workflow versus a tool. We're going to go over some basic programmer workflows, including LLM enhanced and vibe coded workflow. Cover what is tech debt, how humans understand humans' problems, why an LLM can never understand systems, and then finally assessing which workflow is best for you. And workflow is a process you take to solve a problem. It could be a bug, could be a feature, could be a change. A tool is a resource that you use to aid you during that process. And a step in the workflow might be to investigate what is causing a bug. A tool could be technical doco, release notes, Stack Overflow, or an LLM query. When a tool performs the entire step, it's no longer a tool, but a part of the workflow itself. And then once enough of the workflow is replaced, a human no longer understands what has changed and why, and probably has no understanding of what is in the code. A basic traditional programmer workflow here between bugs and features. On the left, the PO, SME, stakeholder will log the bug report. And then once the programmer gets it, they validate it to make sure that they understand the problem. And once they understand it, they can begin to investigate what's caused it. They have a bunch of tools at their disposal off to the side of it, such as logs, documentation, support tickets, Stack Overflow, blogs, experts exchange in the old days, forums. And then once they've worked out what might cause it, they take probably the most important step in bug fixing, which is to reproduce it, where you turn the bug off and on. If you can't do that, then you really don't know what has caused the bug, because it could be transient, it could be a race condition, it could be caused by multiple things. Then once it's fixed, implement it, a tester will get it. They will create test cases. They might do manual testing, automated testing. If it has been resolved, it gets deployed, and sometimes they might wish to create a regression item to test it in the next sprint. A very important feature is that at any point, you can go back a step, because if something's going wrong, you may need to reassess where you're at. Then for the feature, the SME or PO or stakeholder will create a feature. They will have tools of their own that they use, such as the roadmap. If it's a PO, they might be making use of SMEs. They might have requests from users. There might be new reporting requirements, either internal or maybe governmental reporting, so the feature needs to come out. The PO who is making this feature, they might use some of the same features that the programmer would, such as wikis, architecture documentation. They might look at surrounding sprints to get an understanding of what has been and what's coming up. They might use the roadmap, and they may have application goals they need to consult. And the programmer will use those same tools while they're analysing the request to make sure they understand how the feature should work. After that, they will check, does this fit the system? And then they'll begin to implement it, and they need to make sure that it is fit for purpose and system appropriate while they do. And they'll use a bunch of tools such as documentation, Stack Overflow, blogs, forums, expert exchange. Then finally, they perform their local testing. They'll go to a tester who will then need to analyse it themselves to understand the scope of it, work out how they're going to test it. They're going to use probably the same tools as well. There's really going to be the wikis, the architecture, the surrounding sprints, the roadmap, application goals. They'll create the tests detailing what and how they test it. Then if there's problems, they'll log bugs about what went wrong. They'll be using their test cases, manual testing, automated testing like they would with a bug. And then finally, it goes to deployment. And of course, this is just high level, a little bit reductive, and the steps can get compressed in certain cases. With the advent of LLMs, we have an amazing tool at our disposal, and we can insert the tools in the process to give us a lot of boosts in productivity and potentially quite an improvement in quality as well. So on the left, when a bug gets reported, the LLM could assist in the bug validation and description. Both the PO and the programmer could benefit from that. While investigating, very often bugs are very quick to fix and diagnose anyway, but difficult bugs can be assisted with an LLM that can speed it up a lot, and it can also create more robust fixes if it can identify more causes. Then, while implementing the fix, the LLM can be used to validate that maybe it's done the job. It's a good second set of eyes. You can ensure that the final code is safe and also check for side effects. Then the tester also gets a lot of benefits, because the tester can get assistance with writing test cases and also with creating automated tests that can speed up an awful lot of time. And during the feature creation, the program has quite a lot of benefit from some sanity checks to make sure, does this make sense? They can also check if there's common solutions to problems, and they can then also work out, as a part of what the human has to do as a part of the workflow, work out, does it make sense to implement this common solution? Then during implementation, the LLM can help generate scaffolding, copy patterns from other areas, and it can help make sure that there's no obvious problems with the code as well. Then for the tester, they get the same benefits as they did during the bugs. Once we get to a vibe-coded solution, it doesn't have to go all the way here, but we'll just swing completely to the polar opposite for comparison. We have the old workflow grayed out, which is no longer taken. Now instead, on the left, when a bug report comes in, you might go straight to the LLM, off to the CLI tool, use your good system prompt. I have a bug. I want you to create best practices fix and validate it. All the best things are done. After that, they go into a cycle of barking orders at the LLM. Now this isn't working. I told you not to change any other files. Finally, they get into a place where they like it. Once it's fixed, at this point, only the LLM really knows why the code change fixes it, if they did it all. Compared to the previous workflow, if I've got a pull request in, I will know what every single line of code does. And if something's flagged during review, I can say, that's exactly why we have that line. That's what it does. If there's something wrong with it, I'll pretty much immediately know, oh, that's my mistake. I'll go off and fix it. Then during testing, we'll assume that the prompt engineer, or a different one, is also testing it. They'll have their good testing system prompt to, bug was fixed with this description. Maybe there's an MD file to help create all the tests, and then finally it goes back to deployment. It could go back a step. You could begin barking orders at the LLM again to get it to fix the things that went wrong. Then during a feature, it's a very, very similar process really. It's just a good dev system prompt. You've got a feature with certain requirements, create a best practice implementation and validate that all the best things are done that you want. Go back to barking orders at the LLM. There's a runtime exception now. The query could not be translated. Finally, it's done and it goes back through more or less the same testing procedure at the end. And something of note, of course, is no longer does a human in this process analyze and understand it. They don't do a system check. They don't really make sure it's system appropriate along with that. And you don't really go back a step either if things aren't quite working how they should. So tech debt is when code is no longer fit for purpose. And the baggage may come as code that's more difficult to change, or maybe that code will need more lines of code to make a change. And it also could take the form of bugs that you don't know of that get discovered in production. And whenever you change code without restructuring, it means the surrounding code is no longer fit for purpose. And when you have high velocity changes, you get more code, which means more code is no longer fit for purpose. And this does not immediately present itself. You have a high velocity sprint and everything's fine, right? You have another couple, still might be okay, but over time it builds and builds and builds. And your workflow, such as the traditional one, should be the thing that's shining a light on potential tech debt that's happening because the human is going through each of those deliberate steps. And the more you replace your workflow with tools, the less you can see tech debt until it comes and bites you. Human problems and definitions, they're vague and they are full of inconsistencies, and we all do it and we do it all the time. And they very often include things that provide comfort and convenience. None of us ever talk about the details because they're common knowledge or they're covered by the Epistemic Backchannel. And the Epistemic Backchannel is often non-verbal or sometimes verbal ways that we communicate with each other subtly to indicate what we do and don't know, and very often what we think the other person does and doesn't know. And I've got a video and description about that. Consider a simple user story such as a customer, I need to add a product to cart so that I can keep a track of what I want to buy. That statement there has a lot more unsaid than said. And product owners, SMEs, users, and Programmers, we're completely guilty of this. We default to the vague all the time. And during the workflow, a human will naturally implement the implicit things because it's sitting in their mind and they're thinking about it. Just to dive in some light philosophy about theory of being, theory of mind, comparing a large language model and a human, we'll use such as theory of mind. And for a language model, its essence precedes its existence. So it is designed and then created. It's functionally complete. It's deterministic and has no freedom. And the only reason it ever appears non-deterministic is because temperature is introduced to pick another possibility in response. But if you always use the same temperature, the same seed for the same temperature, you'll always get the same response. And the Chinese room theory could very well be accurate for a description for them. And the only reason they may ever appear to have intentionality is because of their training. And if you've ever used a text large language model, you'll see that it has no intentionality at all. Compared to a human, their existence precedes their essence. So they're born and then they grow. Humans are inconsistent and open, and humans are radically free. I don't mean in terms of physics and neuroscience, because obviously there's no such thing as free will, but philosophically we're radically free, and we're also intentional. So don't hate me for this, it's very reductive, but for illustration purposes it's correct. For V1, you go through your training, fine-tuning, post-training, stores it in the fancy vector database, you give a prompt, you get a deterministic response, and when you want it to be different, you have V2 and you go through all the steps again, store it in the fancy vector database, and you get the prompt for with a deterministic response. Then when we get to the humans, we're born, and as a baby, we don't really exist in any terms of essence philosophically. You give a prompt and you get a purely reactive thing back. You boo and the baby giggles or something. Then as they get desires, they get goals, they get growth, and they learn along the way, and we pick an arbitrary point such as a teenager. They get the philosophical ego, not the tall poppy, but the ego is something that isn't real. It's a created thing, it's emergent from us, and it's our representation of ourselves in the world. It's where we see ourselves, and because we have this fictional creation of our subconscious, that is the thing that gives us our intentionality in the world, really. And so when you give a prompt to the ego, because that's really where it goes, not to the person, you get back a non-deterministic response. And you can even give the same prompt immediately after and get a different response straight away, depending on the topic. Then they get more desires, more goals, more growth, more learning. And as an adult, there's a much larger ego because we've got a much more defined place in the world of where we see ourselves. And you can keep prompting it, and you'll keep getting non-deterministic responses, and that goes on forever during our life. So an LLM, it's extremely good at solving specific pre-trained problems, and because it's good at language, you can apply that language and it will readily give you a good customized solution. However, being a functionally complete unit, an LLM doesn't even know what a system is, let alone what your system is. You can kind of emulate a system's response with careful and detailed prompting. However, the more coded outputs, especially on aging systems, the less fit for purpose your system will be, and the more tech debt you will acquire. So you can really sum it up with the fact that LLMs produce the highest quality code and most fit for purpose code when it is on small, isolated sections which line up well with existing solutions. So finally, it's about assessing which workflow is best for you. And then every workflow will be unique and specific to your domain at hand. You wouldn't go to one place, copy a workflow and use it exactly at another one without any even minute changes to it. So you can ask yourself, do you value velocity or stability and quality? Because you can't have both. And there's nothing wrong with valuing either of them, but you have to work that out. So you can think, how long will your application be around? Is it a 2-year application? Is it even shorter? Is it something that you're just going to throw away after you use it? Or is it going to be 10, 15, 20 years? And how reliable do you need your application to be? Another thing to think about is team cohesion, because the more you use AI, the less your team will communicate with one another. And also, every provider is running at an insane loss, and at some point the price will go up. And do you have a plan for how you're going to cope when inferencing costs skyrocket? And really, you can think that it's the workflow, not the tools, that are going to determine your outcome. And finally, make sure you very carefully assess your product and have a considered business decision on which workflow you use. Have fun coding.